Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Rusli and I am from class CS 24931. Today I'm going to present about my lab assessment. So first of all is the introduction. So the purpose for this assignment is to use the maple command to plot the quadratic surfaces. Quadratic surfaces is a generalization of conic section. The conic section is a curve formed by the intersection of a cone surface with a plane. There are three types of a conic section. The first one is hyperbola, the second is parabola, and the third one is ellipse. So next, I'm going to introduce about the maple. I'm going to use maple for this lab assignment. So maple is a math software that combines the world's most powerful math engine with an interface that makes it extremely easy to analyze, explore, visualize, and solve mathematical problems. With maple, you are not forced to choose between mathematical power and usability, making it the ideal tool for both education and research. So next is the selected question that I picked to do for this assignment. So for the section 1, I choose the equation of J and K. The equation J is x squared equal to y squared plus z squared, and the equation K is y squared equal to 4x squared plus 16z squared. And for the section B, I choose the equation 1 and 3, which is the equation 1 is plot the solid that lies between the cone Z equal to set x squared plus y squared and the plane Z equal to 4. And for the question 3 is plot the solid that is inside the hemisphere Z equal to set 25 minus x squared minus y squared outside the cylinder x squared plus y squared equal to 4 and above the xy plane. So now we will go to the implementation. So for the first question in the section A, the question J is plot the x squared equal to y squared plus z squared. So the method that I use in the maple command is implicit plot 3D. So first of all, I set the limit of the x equal to negative 10 until 10, and for y also negative 10 until 10, and for z also negative 10 until 10. After the coding process is settled, this is the final product. So we get the elliptic cone. So what will happen if I change the limit of the command? So first of all, I change the limit z from negative 10 to 10 to 0 to 10. So the output will be different. This is the output after I change the limit of the z. This is still elliptic cone, but this is only half of elliptic cone. Next is for the question 2, which is plot y squared equal to 4x squared plus 16z squared. I also use the implicit plot 3D for this question. So the limit is x equal to negative 110 until 110, and for y is also negative 110 to 110, and for z is also negative 110 to 110. So after the coding process is done, we also get the elliptic cone same as question 1. So what will happen if we change the limit? So I change the limit of y from negative 110 to 110. But we still get the elliptic cone, but the elliptic cone is become half. Now we move on to the section B. Question 1. Plot the solid that lies between the cone Z equal to set x squared plus y squared and the plane Z equal to 4. For this question, I also use the implicit plot 3D in the maple. So I set the limit for x is equal to negative 15 to 15, and for y equal to negative 15 to 15, and for z also negative 15 to 15. After the coding process is done, I get the image of plane lies under the elliptic paraboloid. And this is the last question, which is question 2 for section B. For this question, the question asks me to plot the solid that is inside the hemisphere Z equal to set 25 minus x squared minus y squared outside the cylinder x squared plus y squared equal to 4 and above the xy plane. For this question, I also use the technique of implicit plot 3D. So for the limit of this question, I set the limit of x equal to negative 10 to 10 and y equal to negative 10 to 10 and z also negative 10 to 10. After the command process is done, this is the output that I get. I get the image of the cylindrical surfaces passing through hemisphere. That is all from me. Thank you.